Hey everyone, get ready to dive deep into making those React apps blazing fast. Performance optimization, that's our game today. And get this, we've got some awesome sources to pull from.
Yeah, we do.
We've got, excerpts from the classic React docs, on code
Yeah.
splitting. We've even got insights from Google themselves, their Web Vitals guidelines. And hold on, we've even got a sneak peek at a real training agenda for, React devs.
It's a really good mix. You'll get the theory, the practical stuff.
Yeah, and look, we're assuming you're not totally new to React here. So we're going to go past the basics, into when to use what optimization when it really matters. And those gotchas, those things that trip people up.
Think of it like a masterclass, right?
Yeah.
React performance, all the little details.
Right.
So you can make your apps, well, sing.
All right, I love that. Let's kick things off then. Where do we even start with this stuff? I think we've got to understand how React actually renders, right? Like the whole process.
Yeah.
And we've got, there's an excerpt from the current React docs, render and commit. It breaks it all down.
Gotta grasp this. Because if you don't know why things get slow, you can't optimize, right? It's like...
Oh, it's like trying to fix a car engine.
Yeah.
But you don't know how the parts work, right?
Right, exactly. And this source, they use this restaurant analogy, brilliant, I think, for visualizing this. So, picture this. React is like the waiter, right? Taking orders from the users. And the cooks, back in the kitchen. Those are your components.
Okay, I'm liking this already. So every time a user, I don't know, clicks something, types something, that's like placing an order.
Yeah. So the waiter's got the order, rushes to the kitchen, cooks spring into action, reacts in render mode.
Okay, and each component is figuring out what am I going to display now based on this new info. And this is where it gets interesting, right? Because React is smart. It only updates what's different. It's not like remaking the whole order from scratch.
Exactly. That's efficiency. But it can also be tricky, right? Like, have you ever had this seemingly tiny change, but then bam, the whole app slows to a crawl, tons of re-renders?
Oh, yeah, absolutely. Like one ingredient goes bad and the whole dish is messed up. You know something's wrong. But figuring out what? Ugh.
That's where our code splitting, lazy loading, memosization, all that comes in to fine-tune the dance,
Okay, yeah, I'm seeing how knowing this whole process is key, right? Like, you can make smart choices then. So let's hit code splitting first. We've got this article. It's from the old React blog. A bit dated, sure, but the ideas, man, they still hold up.
Classic for a reason. So think about bundling. When you build a React app, right, it's like packing for a trip. You stuff everything you might need into that suitcase.
But what if you only need, like, your swimsuit and flip-flops when you land? Right?
Exactly. You're lugging around extra weight for nothing. And that's what code splitting solves. Big apps, dashboards. It's like packing those smaller bags. You grab what you need when you need it.
So instead of one giant JavaScript file, we break it up, load on demand. This source mentions dynamic imports, the import function.
Yeah. Like you got all the restaurants in a city, right? But instead of loading every menu at once, you load them when someone actually wants to see the menu.
And then Reacts.lazy and suspense make this smooth for the user, right? Like, while the heavy stuff loads, we show something in its place.
Exactly. Think about like an e-commerce site. Tons of categories. Imagine loading all that code up front. Yikes.
Right. Kill the load time. So with code splitting, you'd load the category, only way less when they go there. And while waiting, boom, nice loading animation. I see the source even mentions route-based splitting.
Perfect for that. It's all about loading what you need, when you need it, users happy, app snappy.
Man, it's wild how something simple like splitting code has such a huge EE impact.
Yeah, it's fundamental. But it's not the only trick up our sleeve. Let's talk about React.memo now. This one's about stopping those unnecessary re-renders right at the component level. And like we said, that can really drain performance.
All right, bring on the React.memo. I'm ready to learn this one.
Yeah.
And when to use it, right? That's key. I feel like this connects to what we were talking about before with the whole rendering lifecycle, but I'm not totally sure how.
You're spot on. It's all about controlling that cascade of re-renders, right? Every time the state updates, this source, they use the term should component update.
Yeah.
For those familiar with, class components. That's what React.memo is essentially doing under the hood with function components.
So it's like a checkpoint at the kitchen door, right? Hold up. Does this order really need to go through the whole cooking process again, or can we just grab the finished dish?
Perfect. That's it. React.memo lets the component say, hey, only update me if my props actually changed, and to know what actually means. We got to talk about shallow comparison.
Ah, yeah, shallow comparison. I've heard the term, but to be honest, I'm a little fuzzy on it. What's the deal there?
It's how React figures out if props changed or not. Imagine comparing two sandwiches, but you only look at the bread. Same bread. React says, hey, same sandwich, even if the fillings are totally different.
Oh, okay. I see the problem there. If React misses those changes, our component won't update right, like getting the wrong sandwich. Not good.
Exactly. That's why we got to understand shallow comparison, right? Be careful what data we pass. As props to these Memoize components, make sure React can see the changes.
Got it. So it's powerful, but not a magic bullet. Got to be smart about it. This makes me wonder, though, have you ever seen like overusing React.memo where it actually makes performance worse?
Oh, yeah, absolutely. It's
Yeah.
like too many cooks in the kitchen, more chaos than help.
So it's a balancing act then. When do we use it? When do we hold back?
That's the million-dollar question, and it leads us to, well, use Memo, use Callback, all these other tools that help us fine-tune things. But before we go there, let's talk about lazy loading.
Oh, yeah. I'm excited for this one. I think that training agenda, we have had some real-world examples of this, right?
It did, and we'll get to those in the next part of our deep dive.
Welcome back. So before we jumped into lazy loading, you mentioned overusing React.memo. And it could actually hurt performance, right? That seems kind of counterintuitive.
Yeah, it can. It's like this. Every time React's got to check, did the props change? That takes a tiny bit of processing power.
Yeah.
But when you've got a ton of Memoized components,
Yeah.
all those little checks, they add up.
Oh, okay, I see. Like too many security guards checking IDs at a concert. It just creates a bottleneck.
Exactly. So memoization, it's got to be strategic. Which ones do you memoize? Which ones just let them re-render?
And to know that, we need to like understand our app's performance, right? Where are the slow spots? I think the React Profiler can help with that, right? Wasn't that mentioned in our training agenda snippet?
It was, and we'll definitely be diving into that, the profiler and how to measure all this stuff in the next part. But for now, let's stick with lazy loading, not just for components, but, well, other resources too.
Oh, yeah. Images. Right. I'm curious about that one. Our training agenda had a good example with images.
It did. Okay, so images.
Yeah.
They can be big files, right?
Yeah.
Loading them all up front,
Yeah.
especially on site with lots of images.
Yeah.
It can really slow down that initial load.
Right. And that hits one of those core web vitals, right? Largest contentful paint, LCP, slow LCP, bad user experience.
Exactly. So lazy loading images, we're basically saying hold off on loading those until we actually need them. The user doesn't see it yet, don't bother.
Makes sense. But how does it actually work? What's the magic behind it?
The magic, well, in this case, it's a browser API called Intersection Observer. Don't worry, we won't get too technical. But it basically tells you when something comes into view on the screen.
Oh, okay. It's
Fire.
like a lookout on a ship, right?
Yeah.
Land ho when they see the shore. So the image is the land and the intersection observer is.
Haha, perfect. Yeah. And once that land ho happens,
Mm.
the image is visible. Boom, we trigger the loading.
So in React, how would we do that in code? Didn't the agenda have something about like use state, use effect?
It did. It showed how to make a custom lazy image component.
Mm.
So at first, it just shows a placeholder, maybe a loading spinner or a low-res version of the image.
So the user sees something immediately, keeps the experience smooth, even if the full image isn't there yet.
Exactly. And then with use effect, we set up that intersection observer. It's watching our lazy image. As soon as it's in view, the observer triggers a state update.
And that state update swaps in the real full res image.
Bingo. It's clever, right? Only loads when needed, app feels faster, saves bandwidth.
Wow, yeah, that's really cool. Just images alone, so much potential there. But zooming out a bit, could we use lazy loading for other stuff, not just components and images?
Absolutely. Think about giant data tables, complex charts, even whole sections of your app that maybe you don't need right away. Lazy loading can delay all that until it's relevant.
So like a dashboard with multiple tabs, you'd only load the tab's content when they actually click on it.
Precisely. It's about choosing what to load up front and what can wait, based on what the user's doing, right?
This is really coming together now. So we've got code splitting, breaking the app up, React.memo, optimizing the components themselves, and lazy loading to delay what we can. Anything else? Any other big techniques we should know?
I think we've hit the most important ones, the ones you'll use a lot. There's more advanced stuff like virtualizing lists.
Yeah.
It's great for super long lists of data. But before we get there, I think we need to shift gears from the how to the how well.
Oh, okay. I like that. So we've learned the techniques, but how do we know if they're working? Like actually making a difference, performance monitoring, right?
You got it. Optimizing without measuring. It's like cooking without tasting. Might be doing it right, but who knows? And speaking of, our training agenda has some good points on this too.
All right, let's get into the measuring tools then. turn those feelings about performance into actual data, right?
Right. So first, which metrics even matter? We talked about Core Web Vitals. Those are great, user-focused. Google's giving us the yardstick, right? But those are the results. To fix the problems, we need tools that show us what's happening inside.
Okay, so what can we use for that? The React Profiler, right?
Yep. It's built into the React DevTools. You can record, analyze, see how each component performs, how often it renders, what's triggering it. It's like an EKG for your app.
Oh, wow. So we can really see in detail which components are the slow ones.
Got it. It's amazing for finding those bottlenecks. You know where to focus your efforts.
This is awesome. I can see how the profiler would be like a game changer. Make sure our optimizations are actually working. But the profiler's just one piece, right? We still need those core web vitals, LCP, FID, CLS.
Absolutely. The profiler is the internal view. The Core Web Vitals are how it feels to the user.
Yeah.
Right. And that's what we're ultimately aiming for.
Okay, so it's like two different lenses. We need both to get the whole picture. But even with all this data, it can still be a lot, right? Where do you even start? How do you pick what to optimize first?
Great questions. And that takes us to the final part of our deep dive. We'll look at the when to optimize, the why bother. Strategies, setting realistic goals, making those apps perform without getting lost in the weeds.
Sounds good to me. Can't wait to see how we can make all this actionable real-world stuff. Okay, so we're back, and it's time to tackle the big question. When does performance optimization actually become a priority? Because sure, everyone wants a fast app, but we've only got so much time, right?
Yeah, I mean, it's the classic struggle, right? Do we build new stuff or polish what we got? Tough call sometimes.
It is. And it's easy to get caught up, chasing those milliseconds, trying to optimize every little thing. But that can backfire, right? Like you end up slowing yourself down in the long run. Premature optimization, I think they call it.
Absolutely. Got to be strategic. Data-driven, not just throwing every trick at the problem. We got to focus on what really matters to the user. And to do that, we need data.
Okay, so data. How do we get it? We've got the React Profiler, the Core Web Vitals. Are those our main tools?
They are. But think of them like different views, right? The profiler, that's super detailed, component level. You see those bottlenecks, how everything's interacting. But then the Core Web Vitals, those are high level, right? The user's experience, how fast the page load, how responsive is it, does stuff jump around visually.
So it's like a microscope and a telescope, I guess. Need both to see the whole picture. But even with all that, where do we start? How do we decide what to optimize first?
Great question. Honestly, start with those Core Web Vital scores. LCP, largest contentful paint, if that's bad. You got to speed up that initial load, lazy loading images, code splitting, stuff we talked about.
Right. And if FID is bad, first input delay, that means something's blocking the user, like a long task or too many re-renders. Memoization, cleaning up those event handlers, that's where you'd focus.
Exactly. CLS, cumulative layout shift, that's about stuff jumping around visually. Got to make sure images load smoothly, dynamic content updates don't mess things up. So yeah, those Core Web Vitals, they're like a roadmap.
Okay, that's super helpful, like a performance prescription for your app. But what about the why bother part? We've talked about user experience, but are there other reasons? Like, why should a business care about this?
Oh, beyond happy users. Totally. There's a business case too, for sure. Studies show, like slow websites, slow apps. People bounce, they don't convert, you lose money.
Oh, wow. Yeah, I hadn't really thought about that, the money part. But it makes sense. Nowadays, nobody's got patience for a slow app. They'll just go somewhere else.
Exactly. Performance isn't just about, being a good coder.
Yeah.
It's a competitive edge. You stand out, people have a good experience, they stick around.
This has been amazing. Seriously, my whole view on this has changed. It's not about those tiny gains. It's about strategy, right? Right technique at the right time. Happy user, happy business.
Glad to hear it. And remember, this is a journey, right? Keep learning, keep testing, keep measuring. And above all, keep the user in mind. That's what matters most.
I just couldn't have said it better myself. Well, everyone, that's our deep dive into React performance optimization. Hope you enjoyed it. And until next time, happy coding.